Okay, and we're going to continue with probability, and this time we're going to look at what's called conditional probability. So I've got a diagram here that potentially would show all of my students. France, Sweden, and USA are the three countries I have students from. Of course, this is fictional data, but we'll use it for this example. I'm going to abbreviate F as France, S as Sweden, U as USA, G as girl, and B as boy, as would be natural. And the dark circle here are the girl students. Outside of the dark circle, the rest of them are boy students, obviously. We'll have no intersex students in this particular example. So we have 20 boys from France, 10 girls, 8 boys from Sweden, 32 girls, 15 and 15 from the US. So, and that totals to 100, so that'll make the math easy here. It won't always be so simple. You can use a calculator, but for our example, it'll be quite easy. It's probability a student is a girl, picked at random. Okay, there's 100 total. So using the basic law of probability, I'll put my total on the bottom. How many are girls? Okay, 10 plus 32 is 42, 52, 57. Probability is 57 over 100 or 0.57. Probability is a boy. Well, we calculate up the boys, and obviously we have an obvious way of seeing that as well. 28, 38, 43. 43 over 100, and not surprisingly, 0.43. Girl and boy are opposites. Not boy is girl, and those two need to add to 1 or 100% if you're working in percents. Probability a student is from Sweden. Well, we have 40 students from Sweden out of 100. So these are fairly basic and easy probabilities. Now this symbol here, when you see a line, probability of A given B is how we read this. This line here means given. Everything after that line is given. We know it happened. So this is telling me I know the students from Sweden. So how this situation arises. I come back to my office, and my secretary says, a student called and they're coming by to meet you. I say, which student? I don't know, but the name sounded Swedish. So I know the student is from Sweden. So what's probably going to be visited by a girl student rather than a boy student if I know they're from Sweden? Now this is where things begin to change. Once I'm given something, my world, my total count is not these 100 students. This student is from Sweden, so my world just changed. US and France evaporated. My whole world is now 40 students. So my total on the bottom is 40 because they're only being considered if they're from Sweden. Out of those, 32 are girls. So 32 over 40. All right, I do need a calculator. Too tired from my trip to Vegas to do this kind of stuff in my head. I get a probability of 0.8. Guess that's not a surprise if I think about it for a second. Now, how would I read this one here? Probability of S given G. So I come back, my secretary says a student called, it was a girl's voice. Well, I wonder if they're from Sweden or France or the US. So in this case, I know the student is a girl. So I've lost everything outside of this ellipse. So I have the girls. So let's total that up. Well, we already did that. There were 57 girls. And I'm curious, what are the odds I'm going to have a Swedish student visiting me? Well, 32 out of 57. And what's the probability they're not from Sweden if I know the student is a boy? So I come back, the secretary says, oh, some guy called, he wants to meet with you after class. Well, I know they're in the boy group, which we already know is 43 students. So that's my total world. If I know they're a boy, I'm in these three numbers here, 43. And how many of those are not from Sweden? Well, we eliminate Sweden, we get 35. Pretty high probability they're not from Sweden if they're a boy. 35 over 43, 0.813, 0.14 actually if I round properly. So if I'm given they're a boy, they're probably not going to be from Sweden. And we can kind of see that. There were preponderance of girls from Sweden anyway. So this is how we do conditional probability. Next example will involve a Bayesian probability, which is a form of conditional probability.